Bismillah. Hello, welcome back. This is the second lecture of the matrix and the 11th lecture in the 12th lecture in the Matlab. We shall resume our matrix questions. We got the sum of all rows. 4 rows are there and these are the 4 totals. Now the next question is, assign the even numbered columns of A to B. Even numbered columns, that is column number 2, column number 4. That is, I want to assign these column elements to another variable B. Therefore, the simple answer will be like this one. The B is equal to A of, take all the row. Now I could have given only, because the size is equal to only the 2 comma 4, then I could have given only 2 comma 4, or if the larger size is there, we can extend using a colon operator. So from the second column to the last column, add 2 columns, that is 2, then 2 plus 2 equal to 4, then 4 plus 2 equal to 6, then 6 plus 2 is equal to 8. Like this, up to second column to the last column, take 2 increments. Here only 5 columns are there, therefore the second column 29, 45, 57, 97 is extracted, and then 2 plus 2 is equal to 4, therefore the fourth column 66, 53, 69, 66 is extracted. If there was one more column, then it would have come, but here only columns are only 5 columns, therefore it had taken even columns, second column and the fourth column. Right, the next question is, assign the odd number of rows to C. Odd number of rows, that is, take row 1, then take row 3, and no more rows are there because only 4 rows are there, therefore we can get 1 and 3 only. Therefore I can either use the AND operator or I can use the specific number. Therefore take the first row all columns, first row all columns, then this is the step value 2, therefore the next time 3, third row all columns, third row all columns are taken. Therefore if you see here, the first 95 to 17 is extracted, then the second one, the third one 5 to 99, 5 to 99 is extracted. We have used the AND operator so that it can work in any size of the matrix. If the size of the matrix is known, you could have simply written 1 comma 3 instead of 1 colon 2 colon AND. Right, the next question is, delete the last row. Last row means here I could use the AND operator, and this is how an element is deleted. Now right now the size is equal to A and I want to delete the last row. Last row means this is end of colon, therefore I can use the operator. Therefore here we can use the operator. Which question I was discussing? I was discussing the question E. Right. Which one? Delete the, yes, this one. So this one becomes A of end, that is, take the last row all columns is equal to an empty vector, bracket indicates an empty vector. Therefore the last row all the columns are made empty, therefore the size is equal to only from up to 95 to 99. This 73, 97 is deleted, therefore we get only 3 rows and 5 columns. Therefore I get only 3 rows and 5 columns, the last row is deleted. Right, the next question is, convert A to 4 cross 3 array. Now right now it has 1, 2, 3, 4, 5. 5 elements are there and 3 rows are there. So 4 into 3 into 4, 15. I cannot convert this one A to 4 cross 3 because it is we want to, I cannot use it because yes, 5 comma 3, not 4 comma 3, this is 5 comma 3. Let us change it, assume that this one is 5 cross 3 because totally 3 into 5, 15 values are there. I can make it as I can make this one is equal to 5 cross 3, 5 cross 3, 15, and 3 cross 5, 15. This one is wrong. This should have been 5 cross 3, right? So the command is reshape. What is to be reshaped? The matrix A is to be reshaped of how many rows? 5 rows and 3 columns. Therefore totally here already 15 values are there, and here also 5 into 3 15 values are there. The only thing is it is made rows, the size is reshaped. 95, the next one is 92, then 5, then next number 29, 45. All these consecutive values become one column. Then 56, 44, 101, 33, 66 becomes the second column. Then 53, 69, 17, 12, 99, they become the second column. Only the matrix is reshaped without affecting the number of numbers in it. Right, the next question is, we have discussed up to G. We discussed up to G, right. The next question is, compute the reciprocal of each element of A. Right, this is my A and I want to find the reciprocal. Reciprocal means 1 by A. Since A happens to be a matrix, I cannot directly use 1 by A. We have to use the element wise operation. Therefore 1 dot divided by A. Therefore 1 divided by 95 will give me this answer, and then 1 divided by 29 will give me the second answer, and so on. Last one, 1 divided by 99 gives me 0.0101. Alright, and the next reciprocal. Please remember that in case of a vector and matrices, it is not the division, it is a element wise division. Therefore this is 1 dot divided by A. Right, the next question is, remove the second column of A. So my matrix A is this one. The second column means all the rows. Therefore A colon of 2 should be the blank vector. Therefore this is my command to remove the second column. That is, all the rows of the second column is to be made as empty. Therefore here you can see that this 29, 45, 57 is no more. Directly it is 95, then after that 44, 95, then 44. The second column is deleted. Now the size of the A is, instead of 3, 5. Now since one column is deleted, it has become 3 cross 4. Right, the next question is, the next one is, here this is, add a row of all ones at the top and ones at the bottom of A. That is, this one I have to add 1 here at the top, and likewise 1 at the bottom. So here I can use this command, this one, A of ones of, how many columns are there? 4 columns. Therefore A of 1, 4 will give me 1. Therefore I create 1. Then I put a semicolon, therefore it is next column. Then I put the matrix A itself, therefore this matrix A is repeated. Then in the next column, again ones are made with 4 consecutive ones. Therefore at the top I add 4 number of ones, at the bottom I add 4 number of ones, and in between I keep the matrix A itself. If I avoid a semicolon, then all these values will be continuous. I put a semicolon, therefore it can come as a next row. Right, so this 1 is generated by this. A semicolon takes me to the next row, and the matrix A is repeated, and then the semicolon takes me to the next row, and ones of 1, 4, 4 number of ones are generated. Right, the next question is, create a 5 cross 5 square matrix with 1 to 25. So 1 to 25, I can generate 1 to 25 using the colon operator. Therefore first I generate a number A equal to 1 colon 25. Therefore A is now 1 to 25. Now from this I can reshape the matrix, the vector A, with 5 rows and 5 columns. Totally 25 numbers are there. Therefore without affecting the numbers, I can reshape it to 1 to 25. Therefore Matlab always takes column major order. Therefore it fills the value with 1, 2, 3, 4, 5 up to 25. Now A is a 5 cross 5 matrix. Now next question is, turn the matrix upside down. Upside down is, that is, this matrix is rotated. Therefore this will come up and this vector will come down. Then this last vector will go up and this vector will occupy this position. This center vector will remain as such. Therefore, it is turning upside down. Assume this, hold this one and turn this one like a paper. Therefore, now the command is equal to turn upside down. Therefore, the command is equal to flip upside down. Therefore, flip upside down the matrix A. Therefore, 3, 8, 13, 18, 23. It is as such, and the top two rows have become the bottom and the bottom two rows have become the top. Therefore, it is rotated about the center. The next question is, we can turn from left side to right. If I keep a mirror, then this 5, 4, 4, 3, 2, 1 will come here and the last column will come to the top. Left side is brought to the right side and right side eventually will go to the left side. Therefore, as we are flipping from upside down, we can flip towards the left to right. Therefore, command is flip left to right. Therefore, the command this one, actually the A is equal to 1, 2, 3, 4, 5. It has come here and the last column 21, 22, 23, 25 has come here. Therefore, the matrix is turned. This is a turn from left to right. The next question is, the next one is, find the trace of the matrix. What is the trace of the matrix? The trace of the matrix is the sum of the diagonal elements. Let me take first A so that we can cross check it out. Now the trace is equal to 1 plus 7 plus 13 plus 19 plus 25. That is the sum of the diagonal elements is called as the trace. I can find the trace of the matrix by a simple command. Just to trace. 1 minute. Flip, and the command is, I can find the command trace of EA. Right. This has given me 65. 25 plus 19 plus 13 plus 7 plus 1 has given me 65. In order to find the trace of a matrix, this matrix should be of square type. That is, it should have the same number of rows and columns. Alright. Now let us find two more questions are there. And the next question is, let us extract the diagonal elements. Trace of the matrix I discussed. Now how do I find the next question is, how do I extract the diagonal elements? The diagonal elements extraction is very simple. Simply I can extract the diagonal of A has extracted the diagonal elements 1, 7, 13, 19, 25. This way there is a command called, I can extract the lower triangular matrix, all the elements which are below the diagonal element, by means of triangular lower of A has returned me the diagonal elements and all the elements below the diagonal, and all the elements above the diagonal elements have become 0. Therefore, the triangular lower, the diagonal elements and the lower elements are extracted and the above elements are made 0. Similarly, I can extract the upper triangular matrix by means of upper triangular of A. Therefore, the diagonal and the upper elements are retained and the elements below the diagonal elements are made 0. Then suppose if I want to construct a matrix, next question, create a matrix with say 1, 2, 3, 4 as diagonal elements. So here there are two ways. I can say diagonal, create a vector of either 1, 2, 3, 4. This way I can do it, so that I can create a matrix with diagonal elements 1, 2, 3, 4. Or even a shorter form, instead of giving 1, 2, 3, 4, I could have used the colon operator, 1 colon 4. This will also give me the same thing. With the 1, 2, 3, 4 is made, a matrix is got with this as the diagonal elements. Right, and so this finishes the first exercise in the matrices in Matlab. Remaining we shall see in the next classes, where we will discuss the other things. Please do comment on the videos. Please do subscribe. Your criticism is expected. Thank you so much.